So, good afternoon, everyone. My name is Alana Davis. I am the K-12 Science Professional Learning Specialist here in Cobb, and today we're going to be looking at quarter 3 lessons and units for 5th grade. So, if you see anything cool and you're on the Twitter realm, go ahead and share your experience using that hashtag #EngageCobb or hashtag #CobbScienceRocks and drop that in Twitter. So these are the district priorities and commitments for this 2021-2022 school year. We're going to be touching on prioritized instructional standards and strategically aligned assessment models today. So when we're talking about these lessons and activities, those are the two commitments that we're going to be hitting on. Our balanced science instructional document can be found on our academic website, and this is the document. You'll see that all 4 core subjects have a balanced instruction document, and this is just how we are promoting the instruction of science in Cobb. We're going to give our students a 3-dimensional approach to science. We want to move instruction away from one dimension, that sit and get textbook only kind of science instruction, to utilizing the 3 dimensions of science learning. So what are those? So we have the first dimension, which is up here, which are science and engineering practices. Which are embedded, thank goodness, within our science standards and elements. The second dimension, how scientists and engineers connect things, are through the cross-cutting concepts. That's how they think about things. So they think about it in patterns or cause and effect or systems, energy and stability. And then our third dimension are those disciplinary core ideas, which are the big umbrella ideas of science. Earth science, life science, and then within those core ideas we have the knowledge, those foundational skills and the knowledge we want our science students to grasp onto. So here's what we're going to do today. We're going to look at our quarter 3 standards. I'm going to go over the unit plans and some lesson resources for you, and then answer any questions that you might have. All right, the 5th grade science teaching and learning framework. You can find this in CTLS Teach underneath the course navigator tab. For units, for quarter 3, you're really ending cells and microorganisms and transitioning into physical and chemical changes and touching upon electricity and magnetism. So let's look at these standards a little bit deeper and unpack them. For physical and chemical changes, our overarching priority standard is obtain, evaluate, and communicate information to explain the differences between a physical change and a chemical change. So we know that our SEPs, obtain, evaluate, and communicate information, is embedded within this. And then we have our 3 elements that has the science and engineering practices embedded within it. And then we're going to unpack these and see exactly what we're asking our students to be able to do. So we want them to be able to explain the differences between a physical change and a chemical change. How are they going to do that? 3 ways. We are going to plan and carry out investigations. So that means students are going to actually have to do science with their hands. You might have to demonstrate an investigation for them, or maybe do a demonstration in front of them, but then we actually need to put the learning back in their hands. And they're going to manipulate, separate, and mix dry and liquid materials and communicate collected data to demonstrate examples of only physical change. All right. So manipulating, separating, and mixing. So let's think about what that means. Manipulating, we can crumble up paper and bring it back out, right? Separating a mixture, you could think about a trail mix of some sort. How could we separate that to change something physically? Mixing dry and liquid, to me, this is Kool-Aid or Crystal Light or any kind of juice mixture that we're putting in a solution and mixing that dry solution with the liquid to make something else. And then they're going to have to collect data. right? So we're going to have to figure out a way for our students to work with data on this. And I'm going to give you some examples. Element B, construct an argument based on observations. So right here, we can already tell this science and engineering practice, construct an argument. Students are going to actually have to write something, okay? They're going to have to write an explanation about something. But the second part of that says based on observations. So they're going to be looking at something, observing something. All right, what are they observing? Right here, that the physical changes in the state of water, so we're talking about liquid, are due to temperature differences, which cause small particles that cannot be seen to move differently. If we unpack this, this means that our students need to be able to observe changes in the state of water at different temperatures, and they have to be aware that small particles move differently. So we're going to have to use our bodies, we're going to have to be kinesthetic, we're going to have to pull out some microscopes or find some microscopic images where we can show students the difference between frozen water particles, gas particles, and liquid water particles. Last element, plan and carry out investigations. So same thing, we're going to have to put the learning back in their hands to determine if a chemical change occurred based on observable evidence. Color, gas, temperature change, odor, new substance provided. Now this one's going to have to be very structured. I have a few activities that you can actually take care of this element with students, but we're going to have to produce a chemical change, and students are going to have to observe it, observable evidence, and they're going to have to collect data on it. Okay, so what I'm going to do is, okay, we'll just go to electricity. I was going to just go to, okay, so the second unit, electricity and magnetism, our overarching priority standard is obtain, evaluate, and communicate information to investigate electricity. So we are just investigating with this standard. Now, the second standard with this, our magnetism standard, says obtain, evaluate, and communicate information about magnetism and its relationship to electricity. So when we're investigating electricity, just investigating, our three elements are obtain and combine information from multiple sources to explain the difference between naturally occurring electricity, so static electricity, and human harnessed electricity. So what does multiple sources mean? How do I combine that information? So when we unpack this, we feel that it is multiple sources can mean hands-on. It can mean direct reading. It could mean direct research. Think about it. We want to know the difference between human harnessed and static. So we're going to have to do some hands-on things. We're going to have to play with some things. We're going to have to figure out how we can create static electricity, right? So I have some activities that you can use for this standard because we're combining all this information, we're obtaining information, and we're combining it to explain the difference. So they're going to actually have to write something to explain it to you. B is design and complete a simple electric circuit and explain all the components. That's pretty easy. That's like kind of unpacked into its simplest form. Simple electric circuit and labeling all the components. C, plan and carry out investigations on common materials to determine if they're insulators or conductors. So that means we're going to have to do some hands-on science where we have common materials and they're testing them out. For magnetism, A is construct an argument based on experimental evidence to communicate the differences in function and purpose of an electromagnet and a magnet. So we're going to have an argument. So they're going to have to actually write something based on experimental evidence. So they're going to have to actually figure out the differences in function and purpose of an electromagnet and magnet. They're going to need to see both types. They're going to need to read about it, see it, experiment with it. We need to give them lots of options in order to communicate those differences and have an argument. B is plan and carry out an investigation to observe the interaction between a magnetic field and a magnetic object. This is kind of unpacked to the simplest form as well. We want them hands-on, interacting between a magnetic field and a magnetic object. When I think about this, I think about like the Woolly Bully little iron shavings that we used to play with at, I think I used to always get them at Cracker Barrel or something like that. So this is an example of something, of an investigation that you could do with that. All right, let's move on to phenomenon drive student questioning. So three-dimensional science starts with a phenomenon. If you look at this little infographic, you're going to introduce a new phenomena to students related to the standard, and then students are going to write questions and post them on a driving question board, or you can call it a KWL, you can call it a C-Think Wonder chart. All of them are basically the same, but we want, especially in 5th grade, we want you to scaffold and guide and facilitate questioning so that your students come up with questions on why something is happening and how something is happening. And then everything you do during the unit, the lessons, the investigations, the research, the videos, everything is moving these students to figuring out why, the answer to those questions. So they obtain their answers by doing all the activities, and then you evaluate their answers as they go to determine if they answered the question or if they have more questions to get answers to. And then we're going to communicate their findings. All right, so physical and chemical changes. I've had a lot of teachers say, well, what type of phenomenon would you use for physical and chemical changes? So I would show this video clip after the awesome ad. So this is Elephant toothpaste. I'm sure you've seen it before.
This is actually a hair care product. It's 20 volume. It's hydrogen peroxide, but it's a little stronger than what you might find in the drugstore. And we're going to pour this into, I'm going to put my goggles on here, because if this gets in your eyes, it's not real good. All right, yeah, so there you go. Okay. Safety first.
Let me know if you can't hear the video.
All right. So this is for the grown-ups to do. All right. Then, an interesting ingredient. All right, we can take the goggles off. Yeast, dry yeast, believe it or not. This is going to be our catalyst. Hydrogen peroxide is H2O2, so it's like water, but with an extra oxygen. We're going to try to get that oxygen to come out. So, 1 tablespoon of yeast into this little cup here. There you go. And then 3 tablespoons of water into that. There we go. Taking notes at home, it's on the website. All right. There you go. Stir that up. Okay. All right. Now, while you're doing that, I'm going to add a little bit of dish soap in here. All right, because the dish soap. And let's see. Let's go for red foam. Some color. A little color. There we go. So, hydrogen peroxide, dish soap, and then some yeast. Now it's getting a little.
Is that how we want it?
There's a kind of chunking up on you there.
Yeah.
All right. So that's all right. We're just going to take out the extra here.
Okay.
All right. We only need the stuff that's all watery. There we go. All right, now we got the watery part. All right, so on the count of 3, we're going to try to get even more foam. Count of 3, you're going to pour that in there.
I'm going to put it in.
So yeast, here we'll use our funnel, and hydrogen peroxide, a little dish soap. Go for it.
All right.
There it goes. Let's see if we can get a little more foam this time. Oh, yeah, here, there we go.
Oh, my God.
Now that's pretty good. Look at that.
I love this.
That's good television right there. Look at that.
He's so enthusiastic. So that's an example of a phenomenon clip that you could use. You can find one that's more, let me see, how would I say, more, not so many words. You could actually show it without sound, so the students are actually trying to figure out exactly what to do, but I would just help them create questions about that phenomenon, like, what is a catalyst, or why did where did the foam come from? Things like that. And then you're creating that question board with the students' questions, and you're going to use that board through the duration of the unit. For this particular one, I would propose, after the students come up with their questions, I would kind of guide them to some guided questions, such as how does the liquid turn into a foam substance, and why does it continue to expand, and what causes the liquid to change into foam? So to go along with that standard element where we're planning and carrying out investigations, just to observe whether a physical or a chemical change, I like to use our AIMS resources. Now, these resources are kind of old school. They're correlated to the old GPS standards. However, we can utilize them with GSC because they have data collection, it's hands-on science, it's stations most of the time, or games. So if you look at this activity, it's called Change Matters. In this activity, students are going to identify physical and chemical changes. They're going to classify changes in matter and collect, graph, and analyze data. So you're hitting up two of those standard elements with this activity. And this could be a multi-day activity. You could put this in a station. You could actually put all of these, I believe there's 6 or 7 stations. And you can see they have station cards, and it comes with the procedure that you can put at the observe an ice cube in a plastic cup for a few minutes. Use tongs to dip a small piece of still wool into a cup of vinegar. We know what's going to happen there. Place a spoonful of baking soda in a plastic cup. Fill the film canister with vinegar. What's going to happen there? Cut a small wedge from the apple and place it in a plastic bag. So they're determining on their observation sheet if it's a physical, chemical, or both, and why. And in the Venn diagram, they're going to indicate the proper place of each change. So you can utilize this as an informative assessment piece, this Venn diagram at the end, and then flip it over and have them write that explanation that they need to have about one particular one, or how you know that a physical change has occurred, or how do you know that a chemical change has occurred. So all of these activities are in your physical and chemical change science workshop model unit plan that's posted on CTLS, and I'll show that to you in just a little bit. Okay, next up, I have some chemical, how can you tell if a chemical reaction has taken place? So in this activity, stations again, they're going to conduct tests to check for a chemical reaction. They're going to classify the tests. They're going to identify the production of a gas and a temperature change as evidence of a chemical reaction. You can even use this evidence of a chemical reaction as an anchor chart in your classroom if you wanted to. Same thing here, you have station cards. You have a data sheet for both of them. You're going to calculate the temperature change. You're going to take temperature checks and observations at each station. So 2 really, really good activities for physical and chemical changes. Say you wanted to do something a little different, more steamy, where you're integrating the arts. This activity would actually go with element B, which is the solid, liquid, the 3 states of water, and how temperature is the difference in particles. This is called states of matter, and where you use movement to explore them. So you're going to teach your students different types of movement using movement and dance vocabulary, and then they're going to create their own 8-count dance step to different states of matter. So your students can show going from a solid to a liquid to a gas to a solid to a gas, but they're moving their bodies to show the way the particles move in that state of matter. I've done this with several 5th grade classes and they absolutely love it. And it's one of their favorite activities to do because they get to use their creativity. They can, if you have iPads in your classroom, they can come up with their own beats. There's several websites that students can go to play background music, but it's amazing. I even made little cards that had pictures of different states that matter for water, and that's what I gave them to say, okay, you're going to make an 8-count dance up to these 2 states that matter. So it's something they really love. Another culminating activity for this, another AIMS activity that's really great, is called product testing. And it's the students are trying to figure out the best formula to use to make Glover. So they're using percentages, which is great for math. They're comparing and contrasting properties of matter, and they're recommending a product. So in this activity, they're given 3 different recipes for the Glover, and it gives it to them in percentages. I wonder if I have that one pulled up. Hold on just a second. Let me see. Nope, I don't have that pulled up. Let me see. Let me pull that up really quick for you, so I'm not telling you the wrong thing. Product testing. Here we go. This is a really fun activity to do when you might have a day before a break or as a culminating activity. But what happens is they have 3 formulas. So you just need glue, water, and borax. And as you can see, there's 3 different formulas. And they're going to make all 3 formulas and then put their Glover through product testing. So we have a bounce test, shape retention, imprint, stretch, print transfer, and then you're going to mix each formula with 40 milliliters and see what happens. So it's actually really, really fun. Here's their data sheet. I've done this numerous times with students, and they just absolutely love it. All right, electricity and magnetism. So the anchoring phenomenon that I like to use for this one, show you, is a huge electromagnet machine picking up scrap. Imagine you have some students that might not have ever seen an electromagnet in a junkyard before. I think this is so cool. So this is what I would use for to introduce electricity and magnetism to my students. Same process, gonna create that questioning board to use throughout the unit. Some guiding questions. Since iron and metal are attracted to magnets, how does the crane operator get the magnet to repel off the magnet can? Can you turn a magnet off and on? So some really good activities to do with this. These are all AIMS activities as well, and they're all linked in the unit plan. This is giving students example or showing them exactly what static electricity is, just using 2 balloons and a wooden meter stick. It tells you exactly what to do, but you could use this to actually demonstrate with the student to get them thinking after you show the phenomenon video. This might be what you do on that first day. This AIMS activity right here goes right along with element A and how objects are affected by static. So you have you're going to need a balloon, and students are going to experiment with static electricity and look at some of the properties. So it's telling you blow up your balloon, charge it by rubbing it on a piece of nylon, hair, carpet, whatever you have close, and then it has the students investigating what happens when you put it near a piece of paper, a piece of thread, a pencil, somebody's hair, a book. And over here, I pulled this one so you could see it. Over here, you're going to blow up a second balloon, and you're going to use 2 pieces of thread and tape to hang the balloons 3 to 5 centimeters apart. And you're going to charge one balloon and see how it interacts with plastic wrap, the carpet, pieces of nylon, put your hand in between, hold a ruler in between, paper. So it's really all different types of interactions with that. Conductor and insulator. Element C was how do materials conduct electricity? Which materials conduct electricity? So you're going to test a variety of materials to determine if they are conductors and insulators. And what I love about these activities is it comes with the lab sheets already, and also you have some Venn diagrams that you can use for a formative assessment piece or a ticket out the door at the end. Element B was a simple circuit. How can you make a simple circuit and label all the parts? Included with the unit plan are these reading comprehension passages that are great for your ELL learners because it gives them images, vocabulary, and also examples for them to use. So once your students understand and you have demonstrated how to make a simple circuit, you can allow them to make copper tape simple circuits. So I have included some templates for you to do that as well. So you'll just need copper tape, LED lights, and button batteries. You can do this with partners if you want. This is a template that tells you exactly where to put everything on your circuit, but there's also included in this set are some higher order thinking ones where it just allows the students to come up creatively with their own circuit. Let's see. Love circuits. So if you don't want to do a paper circuit, you could absolutely use anything that you have, alligator clips, light bulbs, batteries, paper clips that you can. One thing I will tell you, if you're making a simple circuit like this one right here with the battery and some wire and a bulb, be careful if you're using a paper clip because those paper clips will get so hot on your students. So if they're holding a paper clip on one end, on the other end, and then a light bulb, be very careful when you do that because I've done that numerous times with students, and we have some students that end up getting their little fingertips burnt. Okay, so everything's going to be uploaded to Sketch, so you can get that there. If you guys will just snap a picture of this QR code or click on the link here, this is a survey for this session. Let me know what I can do better. So if you're going to take that survey, go ahead and hit that for me. And then I am going to stop sharing. All right. Any questions, comments, concerns? I know that physical and chemical changes and electricity and magnetism are challenging to teach, especially if you don't have the content background knowledge. But hopefully with those activities, the AIMS activities that I have put, that's what I wanted to, can you put the survey link in the chat? Absolutely. And I'm going to show you, let me show you exactly where to find the science workshop model. Hold on just a second and I'll put that. I'm going to show you right now, Shannon. Hold on just a second. Okay, here is the link to the survey. Okay, let me share my screen one more time. Okay, so in CTLS, here you go, Shannon. We're in CTLS right now. I'm going to click on 5th grade science. All right, up comes your framework. Over here, green tab, unit navigator. I'm going to go to physical and chemical changes. I'm going to scroll down to topic navigator and then click on instructional strategies. Right here is your physical and chemical changes unit plan. Everything is linked. However, all of the resources that are blue down here will also be found at this link. So if you want to find any of the materials, it's all right here. Okay, so that is physical and chemical changes. And we also have the lessons that we've used in the past too. So nothing is taken away. We just added science workshop model unit plans. Okay, and for electricity and magnetism, same thing. Gonna go to instructional strategies, and it's right there ready for you to download. Same thing. Okay. I'm wondering if there's some extra Ames resources because our schools I cannot be located. Okay, so not sure about that. I know that I know every Title I school has Ames resources. Because they're correlated to GPS, I know we haven't bought any new stuff because I don't think they're coming out with them. So, I have all of the Ames resources that we've had. So if there's something specific that you need, just email me and I'll send you everything I have. I am not allowed to post it on CTLS because of copywriting, but I have it myself and I have my own license and I can send it to you if that makes sense. So all you need to do, Kimberly, is just tell me exactly what you're working on and I'll send you what grade level and I'll send you everything I have. You're welcome. Oh, wait, did I not? Oh, here is the survey. Oh, I don't know why that is so big. There is your survey link. Please fill that out. And thank you guys so much for coming. I greatly appreciate you stopping by. If you would like for me to come help you out in any way I can in your classroom, just hit me up and I would love to come in and see you. So thank you so much for coming by. Everything will be posted to the Sketch website.